Hey everyone, welcome back to the first video of the series. In this series, we're trying to understand physics together. Since I never got real into physics, but I find it extremely interesting, I thought let's learn it together. The idea behind this is that you get a nice introduction into physics, because my goal is to move as fast as possible to a higher physics, so you can actually benefit from my studies. Let's have a look to the first idea, something everybody who gets into physics learns at the beginning, and this is motions. Little disclaimer, because you will see this a lot, I use as for distance. I don't know if this is a common term in English, however, as is a German word, so I don't know if you're going to use this. So if you see as, just remember this is distance. However, the concept will stay the same, because the nice thing about math, the logic, no matter the language, will stay the same. So we're going to have a look firstly at speed. We know speed is nothing else than the distance divided by the time. I think this makes sense if you just imagine this in a graph. For example, here you've got something called an ST diagram. Here we get the distance on the y-axis, and here we've got the time on the x-axis. So let's try to see which correlation between S and T is. If we want to divide S and T, we're searching, for example, let's say we are here, so from this point we want to know our F, our speed. So we're dividing this point and this point. What we are basically doing is we have a look at the slope. Why? Because what we're doing here is nothing else than doing like our normal slope triangle. So you shouldn't forget, here is 0. So if we just write this, we think of this point as 0, and then we're just dividing this point and this point, and this is nothing else than the slope. This makes sense because logically, the faster you go, let's say your speed increases, then, so of course we are at a constant speed, I should add that. So then of course at the same time you are extremely faster because you have a higher speed. Therefore you will have more distance. So logically the slope here will be bigger. As I said, since we can think that speed is a constant, we don't see anything weird like this. So let's define what we talked here about a little bit better, because you will see this idea that you have a look at the changes in physics a lot. So one of the first thing I learned when I talked with somebody who's extremely good in physics, actually he's a professor, he said to me, physics is all about changes in systems. Therefore, we have to understand what changes in a certain system to get like a theory of it. Of course, this is not always true, but especially in the beginning, if you learn about physics, I think personally this idea helps you a lot. Because instead of writing speed is nothing else than distance divided by time, in future we're going to write this. Speed is nothing else than delta. Delta is nothing else than the difference between 2 points. Let's say, for example, the difference, let's say this is xe, we're going to say what xe is, and this is x0. So delta is nothing else than the difference between those points. Oh, sorry, good notes. So we're dividing any delta x, for example, in this case our distance, and we divide this through delta time. I'm going in future, and this is extremely important because you will see this idea, especially in motions, pretty often. I'm going to write E for end position and x0 for the beginning position. Meaning here, our xe is this. So this point here. So if we just want to say, for example, we want to know the speed of here, we're saying this is our xn position. Let's say we want to have the distance from here, the speed from here to, so the speed from here to here, we are going to call this our x0. Then we're just we're just going to plug in the values. Since this here is much bigger than 0, since this here is much bigger than 0, of course, this won't be as, oh, I'm so sorry. This won't be as much as if we take 0. So this will be much smaller. The number what we get will be much smaller. So let's try to see what we did here. We're dividing xn position. We subtract from our n position, xn position, the beginning position, and divide this through time n position, and we subtract time n positions with the beginning position. Oh my god. Yeah. So x0 is always, those are just indication of positions. Maybe I should do this here. Of course, if we want to know like our speed, our delta speed, so for example, what is like the, let's say, the average speed from here and here, let's just take this, we would calculate, if we just know this formula here, we would calculate the speed here and the speed here, and then the only thing we are going to do is the end position, so the speed of this here, and subtract this from this speed here. Okay? Let's try to practice this. In 3 days, an alien UFO, or I don't know how to pronounce this, flies 15,000 kilometers. What's your average speed? So you are the alien. Try to pause the video and try to figure it out. So actually, you don't need any formula here. You just need this idea. So let's say 15,000 kilometers, we know this is our distance. So we're just dividing this by time. So the only thing you actually do have to take is this formula. You don't need this. Because, you know, your beginning situation, so your t, 0, is the beginning, so it's 0, and your speed, your distance, so d0 for example, is also 0, because we're thinking of this, let's say we start here, so at 0, this is our distance, and this is our time, so I'm sorry, it should be consistent, we're starting here, and let's say we fly 15,000, so this is 15,000, around so. Yeah, so we're doing the same thing to understand this process graphically. Of course, most of you will understand this and most of you don't need this idea. But always do one thing. Try to think as logical as possible. If you learn this at the beginning, for example, try to imagine things or situations with graphs, you will have it so much easier in physics and in math. I don't know if actually in physics, but as in math, I'm doing the whole time things with graphical and illustrations. So, yeah. The problem here, if we plug this in, we get 5,000. The problem is, we don't understand really what 5,000 means, because what is it? Kilometers per, so it would be actually, if we would do this, kilometers divided by days. This is not something, we don't want to work with this, so the only thing we are going to do is we multiply this with 1 day divided by 24 hours, because 1 day equals to 24 hours, so we're just dividing this, and what we then get is 208 period 3 kilometers per hour, which is much more nice better to work with. Okay, so I think this is like the basic understanding for speed. Let's have a look to acceleration. So the base understanding here, what we're trying to get is, if we got acceleration, we're looking at the speed. So let's begin with the speed. So we see this is nothing else than delta speed divided by delta time. And this makes sense because we are going with the same idea again here. This is the slope. So we have a look at this point and this point. And we can do something like this, and what we would get is the slope at, it's around the slope around those positions. But since our speed increases, because we want to get, if we do an acceleration that's going faster, we want to just know it here. So this is the reason why it makes sense. So we're just going with the idea of the slope again. So let's try to understand one more thing before we go on. Slope means nothing else than what? Correct, derivation. So our speed is actually nothing else here than the derivation of our S and T diagram. So the slope of ST, right? We plug in a certain x value and we get, so for example this, we would get this point. And if we want to know how big the slope here is, we just want to build the derivation. So this is nothing else than this. Same idea with the acceleration. Since this is nothing else than the slope again, which is building this. It's all about this idea. Again, we try to be as accurate as possible. So we don't want to start with saying, okay, A is nothing else than speed divided by time. Instead, we want to start with delta. So we're always looking at the end and at the beginning position. Let's try to get an algebraic idea what we can do with this. So if we say our A is nothing else than this minus this, S0, I'm sorry, and this minus this, let's try to understand what this is. I think we all can agree. Let's try, because let's think we start at a 0 position, so we can actually write this divided by this in this case, just to make it more simple, but I don't want that you're going to do this. So, but let's stick with this. Again, what is our speed? It's s divided by t, right? So what this is nothing else is s divided by t divided by t. Or, if you would like, trying to get like this, this would be nothing else than s divided by t squared. Okay? So just that you have a look what you're actually doing and why we are going to need this. We're going to need this for understanding why certain formula works and why not. Because if you know the formula for acceleration, you will already see this. At least this seems extremely similar, right? So let's maybe just clarify that this measurement is actually correct. So if we, for example, say meters divided by seconds to square, or let's say kilometers divided to hours square, this is correct. Okay, so don't overthink. This is correct because we can actually think of this like this. So let's have a look at a bit more algebra. Something before we talk about this, let's have a look what this means. So this is just our average speed. Let's say, for example, you drive with your car, and this is like your speed, okay? Because you are at high traffic, sometimes you have you drive faster, you drive slower. Your average speed just is like this. So you want to just know what is your average speed, okay? This is the only thing you're interested in this, and this is this. So this sign just means average. If we talk about acceleration, we are actually using more likely this. Reason for this is because if we don't have an acceleration, so if it's not constant but instead like this, for example, we need this. So we're just taking the average here because otherwise this would be too much calculating. So let's try to get a bit of an understanding. I'm so stupid sometimes. Let's try to get a bit of an understanding how we can do a bit of algebra. So we know the average speed is nothing else than, of course, s and t. And of course, we're going to make delta here because this is nothing else than s end position minus s starting position. Same thing with t. But again, for simplification, let's stick with s and t. Later in the exercise, you can still do delta if it's necessary. Question is, let's say we only know time and speed. Then we don't know our distance. The only thing we are going to make now is, so let's write this again, we multiply by t. Then we get equals s, or s equals this. Pretty easy, right? So let's try to think about constant acceleration. And this is going to be one, so this is like the, we are going to be at the end soon. But this is extremely important to understand this. Let's imagine you drive and you want to have like the middle speed, and you have a constant acceleration, meaning logically acceleration, so it doesn't increase but instead it stays at, let's say, 4 kilometer per hour, 30 kilometer per hour. So we know that our end speed is defined as following. The reason for this is quite simple, because if we think back, we know that this is nothing else than, okay, and if we now multiply this with t, we get a times t equals to speed. Okay, because this is a constant, and this is something you can remember, let's try to understand what constant means. For example, let's take the graph. I'm going to set this up in GeoGebra. So let's think, as this, since we have a constant as acceleration, this is our start speed, and this is going to be our end speed. And let's think what our middle or average speed is. So just have a look. Let's say from 0 to 1. Of course, this here is for x equals 1, we get 2. And this means our middle speed is just at 0.5, and this is 1. So the only thing we are going to do is actually we are taking the half of this. So let's have a look what this means. So this means this is nothing else than, we know our speed at the end position is equal to a times t, and therefore our middle speed is nothing else than 1/2 times a times t. I hope this is clear. Why? Because we're just making the same thing like before. I showed you on GeoGebra. I don't know. So let's try to do a bit more with this, because this itself is nice, but let's for example say we do not have acceleration. So this means we would, for example, need this here, or we don't have speed. So what we're now going to do is we're just taking this formula and trying to plug it in. So what we would get in this case is our distance is nothing else than 1/2 the end position of our speed times t. This makes sense because again we know this is our middle speed, and for this here, this is defined as 1/2 this. Yeah, we're going from our end position, if we have this graph, the half, and then we have our middle speed, so 1/2 times end position times t. Okay, so it's actually the same thing if we do this like our normal formula for distance, but since we want to have the middle speed, which is this here, this is 1/2. So we're replacing this with 1/2. Okay, I hope this idea gets clear. And if we now would plug in again our another formula, because let's say we don't want to have this, which is saying this is nothing else than speed of the end position a times t. Let's plug it in, and this is distance times a times t, which is equal to 1/2 a t squared. And this is the reason why I said maybe, where did I have it? Maybe you should think a bit of this, because yeah, this is, was it? Yeah, okay. Yeah. Distance divided by t squared, and let's go back to this. You see, so we're taking a similar approach in this case, just with the idea that we don't have an a, but we basically did a similar idea. This means we could have from the beginning just said, no, if you for example have a, and you know a is nothing else, then go back, let's have a look. Okay, distance divided by t squared. You could plug it in, of course. This is the nice thing about physics. If you have a variable, you can plug in anything that fits for this variable. So we know distance is therefore nothing else than 1/2 times a times t squared. So that's it. Now we have to understand one last thing. This formula as t equals, or we just can say s, but normally we're going with st, but let's say just distance, equals 1/2 a t squared plus following the beginning position of speed times t. So why do we have to write this? This term just is like the idea that our beginning, the beginning speed. I mean, if we have a beginning, if we have like a beginning speed, we would also have to consider it, because if we remember, therefore, if we just want to have our distance, we would make speed times this. And if we would have a certain speed at the beginning and we have the distance, we would have to consider this as well. But in most cases, this will be 0, because you will start to measure at 0. Let's take an example. Let's say our beginning speed is equal to 5 meters per second, and we have an acceleration of 2 meters with second squared. So we want to know what's the distance for t equals 4. The only thing we now just have to do is we're starting at so as I said, so we have a starting, so this is not equal, so f in this case is not equal to 0. Often it is, but in this case it is equal to 5 meters per second. So let's just place this in a simple formula. So s equals 5 times 4, because the beginning speed is 5 times 4, plus, and now we're just doing the rest, 1/2 times 2 times 4 squared, because of this formula. And if you would just calculate it, so this is 20, this is nothing else than 36 meters. If I don't, yeah, it should be correct. Yeah, it is correct. Okay, perfect. And that's it. So let's say we search for time and distance. We have A and speed. So the question now is, how do we search for if we have like two missing variables? Oh my god, you know what I mean. So let's try to have our simple formula. So the distance is equal to 1/2 a times t squared. Let's try to do some algebra and try to get like those two variables. I maybe should study some English more. What could we work? So we have speed. So let's try to remember what speed is. So we know speed is nothing else than distance between distance divided by time. But oh no, we don't have the distance, so this formula won't work. But let's try to think again. We know that because we have A is nothing else than delta speed divided by delta time. Or let's say just time. And O, we have all three components. So the only thing we're going to do is we multiply by t. So we get AT equals distance, delta speed, and therefore we get this here. Now, the only thing we're going to do is we divide this by A. So we get t equals to end position, start position, divided by A. And this is quite easy. So now we actually would have all components. Now we just plug this in. So what we would get is this is nothing else than 1/2 times this formula squared and times A. Pretty easy. Yeah, that's about it. So with this formula, we would like, what I personally would do is just if you search for something like this, firstly just get like t. So calculate, so plug in your speed and plug in your acceleration, and then just, I mean, this is just so much better. This looks so much better, personally I think. So you don't have to do it that much. Yeah, that's about it to this one. So let's have a look at the last idea here. And this is like the correlation between distance, speed, time, and let's say A. So, so we're searching for the correlation between distance, S, time, T, speed, and acceleration. So, and I think this is actually quite nice. So we know the middle speed. So we know our distance is defined as this. The problem here is we don't have our acceleration in this formula. So the only thing we're going to do, because we're searching for it, we try to do a bit of math, a bit of magic. So we know the middle speed is nothing else than 1/2 times here the end position plus the start position of speed. We remember if we have like our diagram, and this is nothing else than divided by 2. If we remember, let's say we start here and we want to know, for example, from here to here, the middle, we just divide by 2. So by 2. Or we make times 1/2. Doesn't make any difference. If we say we want to go away, if we want to say we are from here to here, we're just taking this plus and plus, because if we now divide this, we would get this point here. This is like this idea of division, why we addition, not division, which is something else. So the distance is nothing else than 1/2. Therefore, times this times, and now we have a new formula. Let's try to get in our A. How can we get this? We just have a look which formula has an A in it, and this has an A in it. So the only thing we're going to do is we're going to say A times T equals to delta V, delta speed, delta V, oh my god. And this is nothing else than if we divide this by A, so we get time equals to delta speed divided by A. And oh, what wonder, no, we have actually an A in it. So now comes a nice algebraic trick. If we have this here, make it a bit more clear. So plus 0 times f and minus 0 divided by a. We can say this is one big fraction, and therefore this is nothing else than 2a times 0. We're just saying this is nothing times 1, because then this is still the same. And we can just think this away and we get this. So now just think at the third binomial formula, which says this is nothing else than a minus b squared equals to a plus b. And oh, this looks like this, so we're just writing this in, and what we actually get is this formula. So if we don't want to, I'm sorry, I defined, we don't want to have a correlation between time, because this would not be possible with the things we define. But the core idea is that distance is nothing else than this. Yeah, because the second binomial formula, this is nothing else than the squared, and then you just make it in a fraction again. Yeah. Pretty easy actually. So let's end this video with one last idea. So let's say we already said, so if we have S and T, so the only thing we are going to do in this case is we're drawing our graph. Let's say this is this. And we know the slope of this here, so this is S and this is T, so the slope of this here is our speed. We already clarified this in the first part of this video. Therefore, this is nothing else than this. And therefore, we know that the equation follows a similar idea. We have this. I think this makes a lot of sense, because if we have a look for this, we just bring the variation, and if we want to come from this to this, we're just blowing the second derivation. The idea here, and I don't know how far you are with calculus, but the idea simply here is then, this is nothing else than, now let's make it a bit better, the integral of at, and for st we have a similar idea. So this was like the idea I had when I saw this. So the speed of t. So we're just playing the integral. Thank you very much for watching. I hope we see us very, very soon. Bye.